Hello, hi everyone. Welcome to the Student Demand. This is your Shiva sir. Today topic is light reflection and refraction. In the previous part, I explained about light reflection. Now I am discussing about light refraction chapter. Sorry, light refraction topic. Okay. So here I am taking this one. This is the rarer medium and denser medium. Speed of light is more in the rarer medium. Speed of light is less in the denser medium. What about 12th class? I'll start. Actually, it's going on. Definitely. Huh? Okay, done. Rarer medium, denser medium. Rarer medium, denser medium. Incident ray. And I'm considering this is the normal line. So this is the refracted ray. Incident ray, refracted ray. Incident ray. Incident ray. So this one is the refracted ray. Refracted ray. Refracted ray. Or actually, if you are taking this surface, so if you are taking this completely one surface, then it is refracted ray. So light ray is bending. Incident ray, refracted ray. The angle between incident ray and normal line is called angle of incidence. So angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. The path of the light changes. The path of the light changes. The path of the light changes when it is moving from rarer medium to denser medium. Or the bending of the light ray at the interference of the two media. The bending of the light ray at the interference of the two media. Okay. So when it is passing from one medium to another medium. Or the path of the light changes when it is moving from one medium to another medium. Any definition we can take. Okay. So here the main motto is, the main point is, what is exactly happening is here, light ray is bending, light ray changing the path. Path of the light ray changes when it is moving from one medium to another medium. Simple, very easy. That's enough. Okay, that's enough. Simple. So no need to worry about it. Just keep in mind, light ray, path of the light ray changes. Path of the light ray changes when it is moving from one medium to another medium. So point number one. Coming to point number two. If the light ray is moving from rarer to denser, it bends towards the normal line. If the same light, so we can take light ray, it's moving from denser to rarer, it moves away from the normal line. Once again, light ray is moving or shifting or bending or moving towards the normal line when it is moving from one medium to another medium. After refraction, refracted ray moves towards the normal line. Refracted ray means changing the light path of the light ray. Okay. So this light ray will move towards the normal line when it is moving from rarer to denser, because refractive index of the medium is greater than the refractive index of denser medium is greater than the rarer medium. Compared to rarer medium, denser medium refractive index is more. Okay. Sir, what is refractive index? What is refractive index? So I'll explain. So here, I hope it is clear about definition of refraction of light. The path of the light changes when it is moving from rarer to denser, or denser to rarer, or simply the light ray changes its direction and it is moving from one medium to another medium. When it is moving from one medium to another medium, path of the light ray changes. That's enough. Simple. So if it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay. Okay, done. Yes. Now laws of refraction. Laws of refraction. Laws of refraction. What are those? Laws of refraction. Point number 1. Incident ray, refracted ray, normal line lies on the same plane. Point number 1. Point number 2. The ratio of sine of angle of incidence to sine of angle of refraction. Refraction equal to constant, that is nothing but n. Constant, that is nothing but n. So very important. So problems will come on this concept, especially on this formula. Okay. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. Ratio of sine of angle of incident to sine of angle of refraction equal to constant. Okay. Done. So when it is moving from rarer to denser, angle of incident is greater than the angle of refraction. Sir, why it is? Point number 1, rarer to denser, moving from rarer to denser. So why it is like this? Rarer to denser. Because so first point is rarer to denser. Light ray is moving from rarer to denser. Because refracted ray moving towards the normal line. Refracted ray is moving towards the normal line. So angle of refraction is less compared to angle of incidence. Second point. So light ray is moving from denser to rarer. So like this. So I'm taking light ray is moving from denser to rarer. Then light ray will move away from it. This is the incident ray, angle of incident and angle of refraction. So in this case, angle of refraction is greater than the angle of incidence. Is it clear? So denser to rarer. Light ray is moving from denser to rarer. Light ray is moving from rarer to denser, it bends towards the normal line. If the light ray is moving from denser to rarer, it moves away from the normal line. Coming to laws of refraction, incident ray, refracted ray, normal line lies on the same plane. And the sine of angle of the ratio of sine of angle of incident to sine of angle of refraction equal to constant, that is nothing but n. That is nothing but refractive index. Sir, what is the refractive index? Refractive index is nothing but the ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called refractive index. This is also called absolute refractive index. Absolute is nothing but absolute refractive index. Why it is called absolute refractive index? Refractive index. Because we are comparing speed of light in medium with respect to speed of light in vacuum or air. So C equal to 3 into 10 power 8 meter per second. C equal to 3 into 10 power 8 meter per second. Okay, na? So refractive index is, so N equal to C by V. That is absolute refractive index. Coming to relative refractive index, so N12 if you are taking, so V2 by V1, or we can also write N2, N1 by N2, N1 by N2 equal to N1 by N2 equal to V2 by V1. Okay, so is it clear? Until here it is clear? Yes. So I hope it is very clear to you all. Then Okay, so this is about refractive index. This is about refractive index and loss of refraction and refraction. Now we'll discuss about critical angle and total internal reflection. Very clearly I will explain, point to point explain. Explanation will be there. So be careful, listen. Okay, now so I'm taking like this normal line. So this is the light ray. Light ray is moving from rarer denser to rarer. Normally if the light ray is moving from denser to rarer, what happens? It moves away from the normal line. So this is the rarer medium and denser medium. Rarer medium and denser medium. So this is the rarer medium and denser medium, rarer medium and denser medium. Okay, so light ray is moving from denser to rarer. Light ray is moving from denser to rarer. So very important, listen carefully. Light ray is moving from denser to rarer. Okay, done. So this is the incident ray. The angle between incident ray and normal line is called angle of incidence. So it moves away from the normal line. The angle between refracted ray and normal line. This is a refracted ray, normal line. Refracted ray and normal line is called angle of refraction. Okay, done. So we know that one. So I'll explain, listen carefully. Okay, so very important, very important. So normally if you are taking light ray is moving, so light ray is moving from rarer to denser. So it keep on moving like this. Keep on moving like this. So it moves away from it. So if you are sending like this at certain angle, the refracted ray passes along the surface. The refracted ray passes along the surface, gazes along the surface, moves along the surface, or moves along the interference. Okay, moves along the interference of the two media. Moves along the interference of the two media at certain angle of incidence. So here you can observe, so light ray is moving from denser to rarer, same, at certain angle of incidence, light ray is passing along the normal line. So this angle is called the angle at which refracted ray, the angle at which, yes, total internal reflection only. This is the total internal reflection. Especially now I am explaining about critical angle. Next, total internal reflection only. We know that refraction is nothing but when light ray is moving from denser to rarer, it moves away from the normal line. Point number 1. Point number 2. At certain angle of incidence, refracted ray passes, gauges, moves along the interference of the two media. That angle is called critical angle. The angle at which refracted ray makes 90 degrees with the normal line. That angle is called critical angle. Okay. So the same light ray is passing from denser to rarer again. Light ray is passing from denser to rarer again. Like this I am taking. So here if you take at certain angle, as I said, so the refracted ray makes more than 90 degrees. Here 90 degrees, then this one theta. So it makes more than 90 degrees. Then light ray reflect back. Okay, refracted ray reflect back into the same medium, into the same denser medium. So it makes more than 90 degrees or more than critical angle. Then this phenomenon is called total internal reflection. So what is the meaning of total internal reflection? Total light internally reflection takes place. Total light internally reflection takes place. That is called total internal reflection. That's enough. Nothing else. Okay. So once again, light ray is moving from denser to rarer, moves away from the normal line. That is a normal refraction. At certain angle of incidence, the refracted ray makes 90 degrees with the normal line or moves along the normal line. So that is called critical angle. So if the refracted ray makes more than critical angle, then reflect back into the same medium. That is called total internal reflection. Total internal reflection. Okay. Total internal reflection. I hope it is very clear. So this is about angle of refraction, critical angle and total internal reflection. Clear? Done. Now we will discuss about one more. I hope it is very clear. Now we will discuss about refractive index little more. So related to refractive index, few problems are there. We'll discuss those problems. I'll explain. Here you can see and glass lab you need to discuss. Anyway, I'll explain the glass lab. After that, we'll discuss the problems. Glass lab. So I'm taking here. So this is the incident ray and this one is the normal line. Refracted ray and this one is the emergent ray. Incident ray, refracted ray, emergent ray. Okay. Now you can observe here. So if you are extending this incident ray, the angle between incident ray and normal line is called angle of incident, and angle between normal line and refracted ray, angle of refraction. The angle between, the distance between, so anyway this is the angle of emergence, angle between normal line and emergent ray. Angle between normal line and emergent ray is angle of emergence. And here you can observe the distance between emergent ray and extended incident ray is called lateral shift. So this is called lateral shift. Okay. And normally if you are taking glass slab and place on the line, so you draw a line on the paper, place the glass slab, it appears to be bent. Okay. So due to refraction of light. And 3 examples I'll give. 3 examples. Point number 1. So you can observe the lemon placed in the beaker, like a normal beaker, water beaker or glass. Okay, so water will be there, and if you place lemon inside of water, so it appears bigger. Point number one. Point number two, if you place the pencil inside of the water, so in the glass beaker, then it appears to be bent at the interference of the two medium. So like first example I'm taking. So here lemon, if you place, it appears to be bigger. Second one, so water is there. So if you place the pencil here, at the interference of the water and air, so it appears to be bent. This is the pencil one. And if you place the coin, okay, so if you place the coin initially, you can't able to see at this position. After pouring water, you can able to see the coin. Okay, so because the coin position appears to be raised, but actually the coin is at the bottom of the beaker. After pouring water, so the coin position appears to be raised. Okay, so here it appears to be here, like this. Actually, this is the vertical. The distance between apparent position to actual position of the coin is called. This is the actual position of the coin. So bottom one. So coin is at the bottom of the beaker. So after pouring water, because of refraction, the coin is appears to be here. Okay. The coin position appears to be at the top. Understood? The coin position appears. There is apparent position. Apparent position. Apparent position of the coin. Okay. I hope it is very clear to you. So this apparent position, this is the actual position of the coin. The distance between apparent position to actual position of the coin is called vertical shift. Vertical shift. So this is about glass slab. So they will ask for 3 marks this concept, especially this concept. Alone 3 marks, they will ask for diagram, only diagram itself. So lateral shift is very important. Incident ray, refracted ray, emergent ray. Angle between incident ray and normal line is called angle of incident. Angle between refracted normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence, right? And the distance between emergent ray and extended incident ray is called lateral shift. And the distance between actual position to apparent position of the coin is called vertical shift. So same thing, bird and fish also same thing. So actually here, this is the water. So actually fish will be here. So bird is flying at the top. Okay. So bird should aim. So actually image will appear here due to refraction. So bird should aim below the image of the fish. So actual image here, image of the fish, actual position of the fish. So here is the bird. So bird should aim the fish. So if bird want to catch the fish, bird should aim below the image of the fish. Okay, this is the image of the fish. So below this one, if it is aimed, then bird can catch the fish. So that also very important. Okay, Bharat. So this question they will ask also very important. Okay. Same thing like vertical shift. It depends on vertical shift. Done. Next, we'll discuss about one more. Spherical lenses. We'll discuss about spherical lenses. Spherical lenses. There are two types are there. So there are two types of spherical lenses. Convex lens and concave lens. convex lens and concave lens. So now we will discuss more carefully about those. So there are two types of lenses, convex lens and concave lens. Convex lens. Convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. Convex lens and concave lens. Whenever the light rays falls on it, uh, sorry, actually I'll teach physics only. So convex lens and concave lens. So ray rules are very important. Ray rules are very important if you are taking convex lens. So principal axis, this is the principal. So principal axis optic center F1, 2F1, F2, 2F2. Sir, why you are taking like this? So if you are taking the convex lens like this, so it is a part of this sphere. This is also part of this sphere. This is principal axis. This is optic center. For this sphere, this is F1 and C1 actually. That way also we can take 2F1, F2 and 2F2. That is also C2 we can take. Okay. So like this we can consider. That's the reason I am taking F1, 2F1, F2, 2F2. So I hope it is very clear. Done? Yes. Now we will discuss about ray rules. Ray rules of convex lens and concave lens. Ray rules of convex lens and concave lens. Now you can observe. So I am taking one light ray like this. After refraction passes through focus. So second one, convex lens. So optic center F1, 2F1, F2, 2F2. Light ray is passing through focus. After refraction, it will become parallel to the principal axis. Coming to the third one. So optic center F1, 2F1, F2, 2F2. Light ray is passing through optic center. Light ray is passing through optic center. Light ray is passing through optic center. So no deviation takes place. It moves in the same direction like this. Okay. So here concave lens. First one is concave lens. Optic center F1, 2F1, F2, 2F2. Light ray is coming parallel to the principal axis. After refraction, it moves away from the normal line. Away from the principal axis. So it passes through focus. Second one, light ray is passing through focus. Optic center F1, 2F1, F2, 2F2. Light ray is passing through focus. So here, after refraction, it will become parallel to the principal axis. And the last one is, so here you can observe, third one. So optic center F1, 2F1, F2, 2F2. Light ray is passing through optic center, then no deviation takes place. Okay, so that's enough. So you can observe here. Point number one, light ray is coming from infinity. After refraction passes through focus. Light ray is passing through focus. After refraction moves towards infinity. Light ray is passing through optic center. No deviation takes place. So light ray is passing after refraction, it moves away from the normal line. Light ray is passing through focus. After refraction, become parallel to the principal axis. Light ray is passing through optic center. No deviation takes place. So this is about convex and concave lens ray rolls. Next, we'll discuss about image formations. Next, we'll discuss about image formations. Now, we'll discuss about convex lens and concave lens image formations. Convex lens image formations. So first one is, so I'm taking the lens here. Optic center F1, 2F1, F2, 2F2. Object is at infinity. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required. Yes or no? So light rays are coming parallel to the principal axis. After refraction, those light rays will meet at focus. Okay, object is at infinity, image is forming at F2. Image is forming at F2. So what is the nature of the image? Nature of the image is so object is at infinity, image is forming at F2. Nature of the image is real and inverted. Size of the image is highly diminished. So coming to the second one. Coming to the second one. Coming to the second one. Optic center F1, 2F1, F2, 2F2. Object is placed oh nice. Hi Akhilesh. How are you? Yeah, I got it. So object is placed beyond TF1. One light I am taking like this. So after refraction it passes through focus. So another light I am taking like this. Okay, so image will form between F2 and 2F2. So here I am taking like this. So F2 and 2F2. So here I am placing the image. Okay, object is placed beyond 2F1. Image will form. So I am good, Akhilesh. I am working for my institution, student the brand. Now come to the point. Object is placed beyond 2F1. Object is placed beyond 2F1. Image is forming between F2 and 2F2. nature of the image is real and inverted, and size of the image is diminished. Diminished is nothing but compared to the object, image size is decreased. Compared to the object, image size is decreased. Okay. So next one, third one. Third one you can observe. Optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. So image also will form at 2F2 itself. So object is placed at 2F1. So one light I am taking like this. Another light ray is passing through optic center. So image will form here. F2 and 2F2. So in this case we'll get same size, real and inverted. Okay. Object is at 2F1. Image is formed at 2F2. Nature of the image is real inverted. Object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted and same size. Real and inverted and same size. Okay. So is it clear? So 1, 2, 3. So object is at infinity, image will form at focus. Nature of the image will form at F2. Nature of the image is real and inverted. Size of the image is highly diminished. Object is placed beyond 2F1. Image will form between F2 and 2F2. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. Size of the image is same size. Very, very important. Size of the image is same size. Okay. So I hope it is very clear. Just check once. So if you want, you can note down. Then, so shall I erase? Okay, done. So next, fourth image formation. We'll discuss about fourth image formation. Fourth image formation. Fourth one, image formation. So optic center F1, 2F1, F2, 2F2. Object is placed between 2F1 and F1. Object is placed between 2F1 and F1. Okay. One light ray I am taking like this. So after refraction it passes through focus. So another light ray is passing through optic center. So the image will form here. Object is placed between 2f1 and f1. Image will form beyond 2f2. Beyond 2f2. Nature of the image is real and inverted. Size of the image is enlarged. Size of the image is enlarged. So compared to the object, image size is increased. Yes, compared to the object, image size is increased. Done. Now, so coming to the fifth one. Optic center f1, 2f1, f2, 2f2. Object is placed at f1. Object is placed at f1. So one light I am taking through focus. So it passes through focus. f2 here. Another light is passing through optic center. So object is at f1. Image is forming at infinity. Object is placed at f1. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Very, very important. Highly enlarged. Size of the image is highly enlarged. Okay. Object is placed at f1. Image is forming at infinity. Nature of the image is real and inverted. And the size of the image is highly enlarged. Okay. Coming to sixth one. Sixth one. So here you can observe sixth one. So optic center f1, 2f1, f2, 2f2. f2 and 2f2. Okay. Object is placed between f1 and O. One light ray I am taking like this. It passes through focus. Another light ray is passing through optic center. So if you are extending these light rays, the image will form here. The image will form. Okay. So observe carefully. Object is placed between f1 and O. Image is forming. Same side of the object. Same side of the object. We are extending the refracted ray. Those are appearing to be mid. That is a virtual image. That is a virtual image. So image is formed beyond 2f1 or same side of the object. Nature of the image is virtual, erect and enlarged. So enlarged compared to the object, image size is increased. Okay, done. That's enough. So this is about convex lens image formations. Point number 1. So like previously I explained 3, 4, 5, 6. These are the 6 image formations. Okay. Next, I'll discuss about concave lens image formation. Concave lens. Now I'll discuss about concave lens. Okay. Be ready for that. So let's start. Concave lens image formation. concave lens image formation. So in concave lens only two image formations are there. In concave lens only two image formations. So observe carefully. So I am taking like this. So optic center F1, 2F1, F2, 2F2. So object is at infinity, image is forming at F1, virtual and erect and diminished. In concave lens only virtual erect and diminished image will form. Always virtual erect and diminished image in concave lens. Concave lens always virtual erect and diminished. Concave lens virtual erect and diminished. So nature of the image is virtual and erect, size of the image is highly diminished. So point number 1. Coming to the point number 2. Actually, these light rays are diverging. Okay, so there is no point. If light rays are converging, it will meet at one point. But those are light rays are diverging, right? So we can't get image, virtual image on the screen. So we are extending those refracted rays. Those refracted rays, if we extend, so those refracted rays appearing to meet at one point, that is focus. Okay, there virtual image will form. Virtual image is yes. So now this is the optic center F1 and 2F1. Optic center F1 and 2F1. So here F2 and 2F2. So light rays object is placed anywhere between optic center and infinity. Object, see, light rays are coming from infinity after refraction. Those are moving away from the principal axis. We are extending those refracted rays. Those refracted rays are meeting extended refracted rays. So that's why I am drawing with the dotted lines. Extended refracted rays are meeting at one point on the principal axis, that is called focus. So here also same thing. So I am taking the object here beyond 2F1. One light ray I am taking, another light ray is passing through optic center. So if you are extending this refracted ray, image will form here. Okay. Now, nature of the image is virtual, erect and diminished. Compared to the object, image size is decreased. So in these two image formations, always virtual, erect and diminished image will form. Right? Yes. Thank you so much. So we'll discuss one more, that is power of lens. Power of lens is nothing but the reciprocal of focal length. The reciprocal of focal length is called power of lens. P equal to 1 by F. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Now, reciprocal of focal length 1 by F. The reciprocal of focal length or degree of converging or diverging of lens achieved is known as power of lens. Okay, the degree of converging or diverging of lens achieved is known as power of lens. So P equal to 1 by F. Power of lens is positive for convex lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Concave lens. For a convex lens, power is positive. For concave lens, power is negative. I hope it is very clear to you all. Right? Yes. Power of lens is positive for convex lens. Power of lens is negative for concave lens. The reciprocal of focal length is called power of lens. Okay, done. So I hope it is very clear to you all. So, is there any doubt? That's enough for today class. Thank you so much for joining, attending, listening, and supporting my channel. If you like the video, if you like my content, if you like the explanation, please do like, share, and subscribe to Student the Brand. So thank you so much. We'll see you in the next class. So if you like the content, please do like, share, and subscribe to Student the Brand. Thank you.